Hi, this is Math 1050, and this video is over Chapter 6A. And in this chapter, we're going to be looking at descriptive statistics. The first thing we're going to look at for descriptive statistics is measuring the center of a data set. There's a couple quantities that we look at, that we measure. For measuring a central tendency, this is a method to numerically describe or identify the central position of the data set. Some of the quantities we use are mean, median, and mode. They are all measures of the center of the data set, but they are calculated differently and under different circumstances. And they also have different importance. Some are more important than others. Some are important in different ways. And so some measures of central tendency are more appropriate and accurate to use in characterizing, analyzing, and interpreting your data. When you have a large sample size, they tend to start to agree though, which is good. All right, so the first one we're going to look at is the arithmetic mean, or the average. You can just think of it as an average. In a sample set, you'll have a certain sample size. We'll have to label it as n, sample size. And the measure of center obtained by adding the values and dividing by the total number of values, or the sample size. Right, so for a data set from a sample, it's the sum of all data values over your sample size. And if we're looking at for a population where you can measure everybody in the population, it's the sum of all data values over the population size. The advantages of the mean: the sample mean drawn from the same population tends to vary less than other measures of center. This is especially since it takes into account every data value, and so just because there's a few possible outliers does not mean that the mean is going to vary all that much. Right. However, the disadvantage is it is sensitive to every data value. And so one extreme value can affect it more dramatically than some of the other measures. But also, it's not going to be as dramatic as some of the other measures that get affected. And so it's not considered a resistant measure of center. And so it can change with outliers. All right, so let's do an example of how to calculate the mean. It's just finding the average. So for this, you want to find the mean of the first 5 counts for chocolate chips in Chips Ahoy. You have counts of 22, 22 again, 26, 24, and 23. And so the mean is the total 22 plus 22 plus 26 plus 24 plus 23 over 5. Alright, so that'd be, let's see, 117 over 5, which comes out to be 23.4 chips. The median, this is the middle value. When the original data value is arranged in order from increasing order of increasing magnitude or size of the numbers. So you just arrange the numbers in order. And so it means it has to be part of a sorted data set. This is a resistant measure of center, so extreme data points do not affect the values. Just to be clear, being resistant has its negative effects. Being non-resistant also has a negative effects. So just because it's resistant doesn't mean it's the best one. Alright, so finding the median depends on whether you have odd numbers or even numbers. So if you have odd numbers, then the middle is just the middle number. So we have here 7 numbers. So we arrange these in order: 0.42, 0.48, 0.66, 0.73, 1.1, 1.1, 5.4. Then the middle number is your 0.73. So your median is 0.73. If we have even numbers, we arrange them in order. So 0.42, 0.48, 0.66, 0.73, 1.1 and 1.1. And then what we do is we average the middle two numbers. So 0.66 plus 0.73 over 2 is going to be 0.695. That is your median. Alright. The third one is the mode. This is the value that occurs with the greatest frequency, or the most common value, the value you see the most. Data sets can have one or more than one mode, or even no mode. So if we have no mode, then no data value is repeated. So in the last set, 1, 2, 3, 6, 7, 8, 9, 10, there is no mode. If we have a bimodal, then 2 data values are repeated with the greatest frequency. So 2 values happen the most, and they have an equal amount of time. In the second data set, you have 55 that happens 3 times, and 27 that happens 3 times. So there's 2 modes. So this is bimodal, 27 and 55. Multimodal is more than 2 data values. That happen with the greatest frequency. Okay. And then a single mode is just when there's one value that happens with the greatest frequency. So in A, 1.1 happens twice. It's the only one that happens more than once. So the mode is 1.1. Okay. The mode is not as telling when you have a small data set. When you have a large data set where there's a lot of repeated values, then the mode becomes way more telling and starts to match the median and the mean as well. All right. So how many peaks would you expect for each of the following situations? Make a rough sketch for each distribution with clearly labeled axes. Length of 500 randomly selected dots, emerald head sharks. Okay, so this is one where you may have some sharks that are smaller. You will have some sharks that are larger, but the most of the sharks are going to be at around some average. So your mode, your mean, even your median, that's too small, right? Mode, mean, median, all towards that center. And so we're looking at one central maximum mode. Right. We call this type of graph a normal distribution. And most natural occurring population type data follows normal distributions. But they can be skewed. So the top photo here, top graph, this will be considered skewed to the right, where the tail is on the right side, and the central hump of the graph is towards the left. And the reason it's skewed is the mode actually will be wherever the top is by definition, and the mean and the median are pushed to the right. Mean pushed more than the median, for that matter. For the other one, skewed left, with the tail on the left side. Again, the mode is always at the top, the mean and the median pushed to the left. Again, the mean pushed more to the left than the median. All right. So for each of these situations, state whether you expect the distribution to be symmetrical, left skewed or right skewed. Right, the prices of 24-ounce containers of 30 assorted brands of dish soap is going to be more symmetrical or normal. There'll be some cheaper brands, some more expensive brands, but there'll be a lot that are going to be at some central mark. Ages of patrons that visit a water park. It's going to be more right skewed. Be more children. So you have lower ages that have a greater hump, and then as the age gets higher, you will have less people that age. Number of applicants completed by new college graduates seeking their first job. This is going to be more left skewed. Many more applications are completed by new college graduates. And so X scale is your number of applications. So it will look like this. All right, now before we go on to 6B, for data sets, there is going to be a calculator that can help you with finding the mean, the median, and the mode for the most part. So on Blackboard, under the QR calculators, there's one, and this is the only one that will use this chapter, called Descriptive Statistics. And this allows us to put in a data set. So let's put in the cookies. We had, just get rid of this. We had 22 chips, 22 chips, 26 chips, 24 chips, 23 chips. So 5 elements. And you get the mean of 23.4, which is what we found when we did it. Also gives us the median, 23. Now it doesn't give us the mode, but it does give us a graph that we can look at, and we can see that the mode is 22. It's the highest bar in histogram. And we'll get into what a histogram is a little bit later, but basically on the horizontal axis you have the number in the data sets are possible, and then the y-axis is how many times they occur. Right. So for this one, the mode will be 22. Everything else on here we'll get to in time. If we look at other data sets, so let's do the one where we found the medium that had odd numbers. So we have 5.4, comma 1.1, comma 0.42, comma 0.73, comma 0.48, 1.1, 0.66. Right, we had a median of 0.73, which is what we found. We now know what the average is, 1.41, and we can look and zoom out sometimes, see where the graph is, and we see 1.1 is your mode, or about 1 for that matter. Okay, this is going to sort these into classes, and we'll get into what that is when we talk about histogram. Alright, so that is 6A. In the next section we'll look at section 6B. I'll see you then.